Alright, ladies and gentlemen, welcome to the video notes for Chapter 1, Lesson 3 in your Algebra 2 textbook. Now, Lesson 3 in your Algebra 2 textbook covers how to solve linear equations. It is a review of an entire chapter of the Algebra 1 book from McGraw-Hill. And it is assumed that it is a full-on review. There's nothing in the section that is considered to be new material. All of this is simply a review of how to solve linear equations. So we'll start off reviewing how to solve one variable equations, which involves using order of operations, or rather reverse order of operations, to solve an equation. So when we look at an equation like example 1, letter A, solve for x, where it says 3x minus 3 equals 114, we are going to do reverse order of operations. Now, normally with order of operations, we do parentheses first, then exponents, then we multiply and divide, then we add and subtract. Well, when we problem solve, we tend to do what is called ESID. We expand, then on each side we combine like terms, then we isolate the variable, and then we divide. So, when we look at this equation and we're being told to solve this equation, we need to isolate. We don't have anything to expand. We don't have anything to combine like terms. We simply need to isolate the variable. So right now, x is not alone on the left side of the equation. We need to get rid of the minus 3. Well, to get rid of minus 3, we simply add 3 to the left side of the equation. Now, in order to keep the equation balanced, we have to do the same thing to the right side of the equation, which would give us 3x equals 117. Once we isolate the variable, which is what we've done here, so that now only the variable is on the left side of the equation, we would then divide both sides of the equation by 3 to get x by itself. So we divide each side by 3. We do 117 divided by 3, and we get x equals 39. Okay, this is a straightforward two-step equation, and that is all we need to do to finish that problem. Letter B is a more advanced example, but again, it is not anything we have not seen before. We are going to expand by distributing the 3 through the first set of parentheses and the negative 2 through the second set of parentheses. That would give us 3x minus 6 equals minus negative 6x plus 2 equals 53. Then we are going to combine like terms on the left side of the equation. 3x and negative 6x will get combined. Negative 6 and positive 2 will get combined. So 3x minus 6x is negative 3x. Negative 6 plus 2 is negative 4 equals 53. Now this is a problem like the first one we solved. We need the negative 3x by itself. We need to isolate the variable. So we are going to add 4 to each side of the equation, which would give us negative 3x equals 57. And then we would divide by negative 3, which would be the last step in our process, divide, to get x equals negative 29. I'm sorry, negative 19. Okay, so x equals negative 19. All right, letter C is an example of an alternative type of directions for the same problem. It says what value of x satisfies the given equation. This is an SAT style question in that the directions are designed to see if you understand exactly what a variable is. In this case, x is the solution to that equation, meaning that it is the value that would make that statement true. If we plug a number in for x on each side, this equal sign would make a true statement. So we're going to solve that equation. We're going to distribute the 7 to expand. Would give us 7x plus 21 equals 8x plus 17. Then we need to isolate the variable. Now this is the first example we've seen where there's an x on both sides of the equation. That simply means that to isolate the variable, we need to move the x to one side of the equation. So in this case, I'm going to subtract 7x from the left side of the equation, which will move that term to the right side of the equation. Now, if I'm moving x to the right side of the equation, then I don't want this 17 to be here. I want it to go to the left side of the equation. So I'm going to also at the same time subtract 17 from each side of the equation. Now you can do that in 2 steps if you prefer. It does not have to be done in 1 step. So that would give us x equals 4, which means the value of x that satisfies a given equation is 4. So the answer here would be B. Okay, the other way the SAT will approach linear equations at the base level is it will give you an equation to solve, 3x plus 12 equals 11, and it will ask you to solve that equation. So we would solve that equation by isolating the variable, subtract 12 from each side, would give us 3x equals negative 1, and then by dividing by 3, which would give us x equals negative 1/3. But then, instead of having that be the answer, because even though it is there, that is not the correct answer, because we were asked what is the value of x plus 4. So we need to take that value of negative 1/3 and we need to plug it in to that expression, negative 1/3 plus 4. Well, negative 1/3 plus 4 would be 11/3, because 4 is 12/3. 12/3 minus 1/3 is 11/3. So x plus 4 would be 11/3. The correct answer would be D. It is very common on the SAT for there to be an intermediate step that you come across as you are problem solving. And 9 times out of 10, your answer to that middle step will be one of your answer choices. But that is never the correct answer to the problem. Again, the key to the SAT is when you think you are done with a problem, you need to go back and make sure that your answer is actually what they're asking you for, that it answers the question that was asked. All right, moving on to the next set of stuff here. Here's some more just examples. We'll go through these rather quickly, especially E and F. On E, it's another one of those examples where they ask us to solve for x and then do something with it. So we would start by solving the equation, 4x plus 8 equals 100. Again, that is your 2-step equation. We need to isolate the variable by subtracting 8 from each side, which would give us 4x equals 92. Then we would divide by 4 to get the value of x. So when we divide 92 by 4, we get that x equals 23. But again, we need to take that value and plug it in to this expression, 12x plus 24. So 12x plus 24 would be 12 times 23 plus 24. Notice 23 was one of the answers again, but it's not the correct answer. So 12 times 23 plus 24 is 300. That is the answer to the question. Okay, on letter F, they didn't give us multiple choice, but it's the same exact problem type. We're going to set up this equation and solve for n. Now notice they're trying to throw us a curveball by having n on both sides without a number. That just means that when we isolate, we are subtracting that 2n from each side of the equation to get n by itself. So subtract 2n from each side of the equation. That gives us 12 equals 28n. Then to get n by itself, we divide by 28. Okay, which gives us that n is 12 over 28, which is a fraction, and does reduce to 3 over 7. If n is 3 over 7, then 7 times n would be 7 times 3 over 7, which would be 3. Okay, G and H are testing your ability to understand equations that have no solution or infinite solutions. Remember that when you have an equation that has no solution or infinite solutions, when you go to isolate the variable, when you move the variable to one side of the equation, it is supposed to cancel out, which means that 6x in this case has to equal h times x. Hopefully everybody can see that means h must be 6 in order for there to be no solution. The same thing would occur for infinite solutions to an extent. Okay, we would start by distributing and we'd be looking at ax plus ab equals 4x plus 10. And it says, in the equation below, a and b are constants. If the equation has infinitely many solutions for x, what is the value of b? Remember that the reason that this equation over here had no solution is because when the x's dropped out, we had 18 equals 12. That's a false statement, which is how we get no solution. Okay, so over here we want this statement, when the x's drop out, to be a true statement, which means, first of all, the x has to drop out, which means when we subtract that 4x from each side, it would have to cancel out, which means that a has to be 4. Because that would allow the x to drop out of the equation, which means if a is 4, then we're really looking at the equation 4b is equal to 10. If 4b is equal to 10, that allows us to find the value of b by dividing each side by 4. b, for an infinite solution, would have to be 5/2. All right. So on into example 2 in your notes, which is how to solve an equation containing a fraction, or in some cases a decimal, and that is through clearing fractions. Okay? When we solve an equation to clear the fraction, what we do is we find the least common denominator, or least common multiple of the denominators, and then we multiply every single term in the equation by that least common denominator. Okay? When we do that, the fractions will all drop out of the equation and leave us with something that does not have fractions. So for instance, on example 2, part A, it says what value of x satisfies the given equation? In other words, solve for x. So the first thing we would do is look at the fractions, and we would say, okay, we have a denominator of 5, a denominator of 5. So the LCD is going to be 5. And we are going to multiply everything in this entire equation, both sides, by 5. Okay, so we are going to do 5 times 2/5 x minus 5 times 7 equals 5 times 12/5 x minus 5 times 2x plus 5 times 3. And I realize I just kind of went over my space there, but it's okay. We'll make it work. Okay? We'll make it work. See if I can shrink it right now. There we go. We'll make it work. Okay? That really didn't work that well, but that's okay. We can fix it. Okay? So, we multiply everything in the entire equation by 5. So we're looking at 5 times 2/5 x minus 5 times 7 equals 5 times 12/5 x minus 5 times 2x plus 5 times 3. Every single term in that entire equation gets multiplied by 5. Now when we do that, what's going to happen is the denominators will cancel into those coefficients and leave us with 1s instead of 5s. And when we multiply all that out, we will have 2x, 1 times 2x is 2x, minus 35 equals 5 times 7. 1 times 12x, which is 12x, minus 5 times 2x is negative 10x, plus 15. From there, we would continue with our basic problem-solving approach. We have expanded. Now we are going to combine. So we'll combine our like terms on the right side, 12x and a negative 10x, to give us 2x minus 35 equals 2x plus 15. Then we would isolate the variable. Well, when we go to isolate the variable, this is what we talked about a minute ago. The x cancels out on both sides. So what we do when the x drops out is we look at what is left. In this case, we have negative 35 equals positive 15. And we ask ourselves, is that statement true or false? That is very much a false statement, which means that this problem has no solution. Okay. On to B, says solve by clearing the fraction. Again, we look at the denominator of 4, and what we need to do is multiply both sides of this equation by 4. Now, because the parentheses x plus 3 is here, that's protected from this multiplication. We really only have one term on each side. So what happens is the 4 on the left cancels and leaves us with a 1. 1 times 3 is 3 times x plus 3 equals 9 times 4, which is 36. We would then distribute the 3, which would give us 3x plus 9 equals 36. That's its expand step. We don't need to combine any like terms, so we move to isolating the variable by subtracting 9 from each side of the equation. That gives us 3x equals 27. And then we divide by 3 to get our answer, x equals 9. Okay, let's do some more. All right, so letter C and D, again, are showing those alternate directions, those alternate steps. So again, we just need to ask ourselves, what is the LCD of 5, 9, and 15? Well, 5 is a prime number, and it goes into 15. So anything we choose for 15 will also work for 5. So what we need really is the LCD of 9 and 15, which is 45. So we're going to need to multiply each term in this equation by 45. Okay, if you're having trouble with the LCD, the other thing you can do is just multiply 5, 9, and 15 together. That number will work as well. The numbers will be big, but it will always work to just multiply all the denominators together and use that number instead of 45. It would work. Okay, so we're looking at 45 times negative 1/5 x minus 45 times 4/9 x equals 45 times 2 over 15. Now this will illustrate the canceling a little bit better than our two previous examples. 45 divided by 5, this 5 would go into 45 9 times. 45 divided by 9, 9 goes into 45 5 times. 45 divided by 15, 15 goes into 45 3 times. Then we multiply what is left. So we have 9 times negative 1x is negative 9x, minus 5 times 4x is 20x, equals 3 times 2, which is 6. Our expand step is complete. Next would be to combine like terms. So we would combine these two together, which would give us, now where'd that x come from? Hold on, I made a mistake here. There should not be an x here. Okay, there should not be an x right there. So let's fix that problem, because that means that's going to change what we do here. Okay, we're looking at this instead. There should not be an x there. It should just be 1/5. All right, sorry about that. So we are going to isolate. There is nothing to combine, so we skip to the isolate step. We add 9 to each side of the equation, which would give us negative 20x equals 15. And then we would divide each side by negative 20 to give us x is negative 15 over 20, which reduces to negative 3/4. All right, so that brings us to our next example, and it will be the last example in this video because I'm running out of recording time right at the moment. Again, we need to ask ourselves, we've got fractions here all the way through. Notice there's a fraction inside the parentheses. So the first thing we should do is distribute through the parentheses to get rid of them because they're going to be in our way. So that would give us negative 31 over 4 minus 7 over 4x equals 7 over 2x plus 3 over 2x minus 6 over 6, which is 1. So in reality, we don't even need this. We can just have 1 there instead. That can cancel, and we can have minus 1. So when we're looking at our denominators, we have denominators of 4 and 2. So the LCD would be 4. So we're going to do 4 times each term. Okay, and it's gotten a little bit crowded there, but that's okay. We can make it work. Okay, we're doing 4 times each of our different terms. Okay, so 4, I'm going to do that from the other end, and I'm going to make this fit a little bit better. Okay, 4 times each term. So we have 4 times negative 31 over 4 minus 4 times 7/4 x equals 4 times 7/2 x plus 4 times 3/2 x minus 4 times 1. So again, the 4's are going to cancel, leaving a 1. The 2's are going to cancel, leaving 2's. Okay, and then we will multiply what is left. So we would be looking at negative 31 minus 7x equals 14x plus 6x minus 4. That takes care of our expand terms. So then we combine like terms. So we have negative 31 minus 7x equals 20x minus 4. Next would be to isolate the variable. So we will add 7x to each side of the equation to move the x to the right side. You could also subtract the 20x. It would make no difference. Since we move the x to the right, we need to move the number to the left by adding 4 to each side of the equation, which would give us negative 27 equals 27x. Final step then is to divide to get the x completely by itself, meaning that x is negative 27 divided by positive 27, or negative 1. That is the first half of the notes. There will be a second video over this lesson that will cover the real-world problems at the end of your notes. We'll take a look at a number of different problem types of real-world SAT-style problems that do employ these problem-solving, these equation-solving skills of expand, combine, isolate, and divide. If you found this video helpful, please like it and subscribe. I do post videos for Algebra 2, Geometry, and Pre-Calculus. There are also videos on my channel for Geometry, for Finite Math, really just high school math in general. So, if you like it, like and subscribe. Thank you.